physical properties. So you have two types of covalent molecules, but okay, so you have the simple covalent molecules and the macromolecules on the right here. So this one is not in your syllabus. So what you do is only the simple covalent molecules. So simple covalent molecules can be like your hydrogen, chlorine, oxygen, water, methane, carbon dioxide that you drew just now. Yeah, I don't think we draw hydrogen. Yeah, I think, did we draw water? No, right? Yeah. But these are simple covalent molecules, and they are very it's very easy to know that they are simple covalent molecules because they are very small. Like this one is only like that. Because they are very small, so they are called simple covalent molecules. So they have weak forces between the molecules, and then there are strong covalent bonds inside. So this is their, I mean, if you want to look at the picture of it, it's something like that. Macromolecules out, don't need to look at it. So you have physical properties here. This whole thing, I think from now on, is all physical properties. So I only talk about the simple molecular compound. The rest, not talking about it. So number one, they have low melting and boiling point. Because remember just now I said they have this one and this one here, which is weak. When you want to melt or boil a simple molecular compound, what you break is these bonds. So because they are, so like something like this. So because they are weak, they don't require so much energy to overcome. So therefore, only a small amount of heat is required. So low melting boiling point. So if you have a structured question and they ask you for the answer, you can simply write this down. Then you can dot add. Therefore, they have low melting and boiling point. No melting and boiling point. Something like that. Let me. Yeah, so therefore low melting and boiling point. After you write all this entire chunk for them. Any questions? Any questions? No. So these are more information. So this one, right, what happens is like this. A lot of students when they want to explain the low melting and boiling point, they often write weak covalent bonds instead of they write this. So they write weak covalent bonds, therefore you have little, therefore you require less energy and the melting and boiling point is low. So a lot of people make this mistake and write this. So I want to bring this point across to you that covalent bonds are not weak. You should be writing, you should write this. You should write this. Wait, okay. You should write this. They have low melting boiling point because of the attractive forces between the covalent molecules are weak. This is the reason, not weak covalent bonds. Then they do not conduct electricity in any states. So the reason is you have to say that they do not contain positive and negative ions that can move freely. Then you have to say that all electrons are in fixed position. So no free mobile electrons or ions act as charge carrier. So when they ask you for why the simple molecule compound do not conduct electricity, you write this. And then the highlighted ones are the essential things that you must include. If not, you get your points cut here and there. Okay? Okay? Can? Then you have this one. They say that they are insoluble in water but soluble in organic solvents. There's nothing much to explain for this one unless you want me to go deep and complicated. So I would suggest you just remember this. So we have this question. Let's just do a quick one. Okay. So you have this, and it's a simple molecular substance. Then they say name forces X and Y. What is this? X is the intermolecular force of Then Y is the covalent bond. Yeah. Yeah. X. Yep. Then this one. Which force will result in relatively low melting boiling point? X or Y? X. Explain your answer. So you can say that the intermolecular forces between molecules are weak, so it requires less energy to break this force to separate the molecules for physical changes to take place. Physical change means melting, boiling is the reference down here. What they're referring to is melting, boiling. Okay, so we can, then this one, why do they not conduct electricity? So you have to say that there is no free moving ions or delocalized electrons, so cannot conduct electricity. So you have to say this, which is the answers here, which is all found in the summary before these questions. Yeah. Then the last physical property I think we mentioned before is insoluble in water, soluble in organic solvents.